Okay, so this is our second example of the addition method. And so let me give it to you here. Example, solve. And we have equation number 1, which is 3x plus 5y equals to minus 6. And equation number 2 is minus 2x is equal to minus 7y plus 4. So now this system has a couple of things going on to it. First of all, the variables are not lined up. The x is on one side, the y is on the other side. You can also note that it is very difficult. If you're trying to decide should I use substitution or addition, if you take that first equation and you try to solve for x, you have to divide by 3. 5 doesn't divide by 3. You try to solve for y, you can divide by 5. 3 can't be divided by 5, nor can 6 be divided by 5. So that's not going to be easy. You're going to get fractions there. Likewise, if you try to divide by -2, you'll notice that 7 can be divided by -2 in the second equation. So and you can't, of course, divide by 7 to solve for y because it's going to be messy. It just won't divide cleanly. So you really don't have good substitution options. So consider using the addition method in this problem. And although there appears to be many steps, it's actually a very easy method to use um, once you get the hang of it. So this is first thing I'm going to do, of course, is to add 7y over and get my variables to line up, right? So variables lined up. Okay, next, nothing is going to go away if I just add straight up. So I've got to do some multiplication to add. So I got to decide on one of the letters. I got to pick a letter. It doesn't matter which one. I'm just going to have to pick a variable to eliminate, right? So I'm going to pick variable to eliminate, right? So in this case, I'm going to think, okay, so I know when I add them, they must cancel. So it'd be nice and convenient if one was positive, one was negative, and I can see that in the x. The y's don't have that, so I'm going to use the x. So in this case, I'm going to eliminate x, right? So I'm going to choose x to eliminate. Now the second problem I run into is, I can't make a 2 into a 3, nor can I make a 3 into a 2 in order to make them cancel. But I can build them both up to 6, which is what I'm going to do. So I'm going to take that first equation, and I'm going to multiply this by 2, and I know if I did that, I'm going to get 6x plus 10y equals to minus 12. And then I'm going to take that second equation, and I'm going to multiply this one by 3. If I did that, I get negative 6x plus 21y equals to 12. And now if I were to add these, the x's will eliminate, right? So the x's cancel out, and I get, what is that, 31y and negative 12, positive 12, 0. Right? So pick a variable to eliminate, adjust the coefficients, and add them together, right? So this is like our next step, step 3. And then this is our step 4, which is to solve, which we are about to do here. So we've got 31y equals to 0. I'm going to divide both sides by 31, and I get y equals to 0. So all of that is step 4. Okay, now that I've got there, what I want to do is I want to find the x. Now that I know y, it's pretty easy to find the x. I can use any one of these equations to figure that out. So I'll use number 2. Right? So number 2 says minus 2x equals to minus 7y plus 4. And so minus 2x is equal to minus 7. And instead of y, I'm going to go to use 0. I should put the minus 7 there. It doesn't really matter. Anyway, plus 4. 7 times 0 is 0. Plus 4, that's 4. And so divide by negative 2, divide by negative 2. X is equal to negative 2. So here is my answer, x, y. So addition method works very nicely. Once you get them lined up, if you know your multiplication, it's pretty easy to use and convenient to use. Okay? So either method works, substitution or addition, but there are times when substitution is a real pain, and this problem would have been horrendous to do with substitution. We do one more example, and then we should be done with the addition method. So example, solve. And so this time we'll do 3x minus 2y equals to 1, and minus 6x plus 4y equals to 5. So again, I've got to decide which method I'm going to use, and substitution is hard to use on this one because to solve for one of the letters is difficult. So I'm going to switch to addition. So when I'm switched to addition, I'm going to decide on one of the variables to get rid of. Doesn't matter, both seem to have a plus and a minus involved. Now let me go after the y. So to go after the y means I would have to turn this into a 4, and that's easy to do. I'd multiply by 2. Okay, so notice how, by the way, when I do these problems, I always write the equations in pairs, even if I don't mess with the second equation. It really does help me keep things organized and together. So there's my first equation. I'm multiplying through by 2. So that's going to give me a 6x. And then that's going to give me a negative 4y. And this is going to give me a positive 2. And here is my second equation. So that second equation I did nothing to, and that's okay. Just write it down. Otherwise, you're likely to forget something. So they always happen in pairs, the two equations. There it is, even though I did nothing to it. And now I'm going to add them. So again, be true, meaning 6x minus 6x is 0. Okay, and minus 4y plus 4y is 0. And that's okay. So be brave. 2 plus 5 is 7. So what we end up with is 0 equals 7. Now this is not something that you should be scared of, right? We've recognized this situation. This is the no variables and false statement, right? This is false. And we know what that means, which means this means there is no solution, right? There is no solution. These lines don't meet. That's the interpretation. These lines don't meet, right? The technical phrase for this is inconsistent. Inconsistent. Okay, just like with the substitution method, the same situations can happen. You could get a consistent answer like we saw in that first example. Something could be inconsistent. Also, something could be dependent. And the way you recognize that is the exact same way. No variables and a true statement, in which case it will be dependent. That's it for the two algebraic methods for solving a system of equations.